Hey there, science fans! Today we're diving into the amazing world of the periodic table. It's like a giant chessboard, but instead of kings and queens, we have elements. These are the building blocks of everything around us, from the air we breathe to the phones in our pockets. Isn't that cool? Now, the periodic table isn't just a random jumble of elements. It's carefully organized into rows and columns, called periods and groups. Each group, or vertical column, contains elements that share similar properties. Think of it like this. Elements in the same group are like siblings. They have a lot in common. Why is this important? Well, understanding these groups helps us predict how elements will behave and react with each other. It's like having a superpower that lets you understand the basic ingredients of the universe. So buckle up as we journey through each group, exploring their unique characteristics and maybe even busting a few myths along the way. Ready? Let's go! First up, let's meet the alkali metals in Group 1. Elements: lithium, Li, sodium, Na, potassium, K, rubidium, Arb, cesium, Cs, francium, Far. These metals are like the life of the party, always ready to react. They're soft and silvery, and they love to lose an electron, making them highly reactive. Ever dropped a tiny piece of sodium in water? It fizzes and explodes, releasing hydrogen gas. Talk about dramatic. But wait, there's an exception. Hydrogen sits at the top of Group 1, but it's not a metal at all. It's a gas. It's like that one friend who always tags along even though they're a little different. Next door we have the alkaline earth metals in Group 2. Elements: beryllium, B, magnesium, Mg, calcium, Ka, strontium, senior, barium, Ba, radium, Ra. These guys are a bit more laid back than their alkali neighbors. They're still reactive, but not as explosive. They're harder and denser, and they're found in all sorts of cool places like rocks, bones, and even fireworks. Remember magnesium? It burns with a super bright white light, making it perfect for those dazzling firework displays. Now, here's a fun fact. Beryllium, the first element in Group 2, is a bit of a rebel. It doesn't react with water like the others. See, even in the periodic table, there are always rule breakers. Now, hold on to your hats as we enter the vast territory of the transition metals, spanning Groups 3 through 12. These metals are the real heavyweights of the periodic table. They're strong, shiny, and have high melting points, making them perfect for building stuff like bridges, cars, and even spacecraft. Think of iron, the most common element on Earth, or copper, used in electrical wiring. We use these metals every single day. Now here's the thing about transition metals. They're a bit more complex. They can lose a varying number of electrons, which makes them super versatile, but also a bit unpredictable. Moving on to Group 13, we meet the boron group, named after the first element in the column. Boron is a bit of an oddball, a metalloid, which means it has properties of both metals and nonmetals. It's used in everything from laundry detergent to bulletproof vests. Section 4. Unraveling the mysteries of carbon, nitrogen, and oxygen groups. Get ready for some serious star power as we explore Group 14, the carbon group. Carbon, the backbone of life as we know it, is the star of the show. It forms the basis of DNA, proteins, and pretty much every living thing on Earth. But carbon isn't just about life, it's also about bling. Diamond, the hardest naturally occurring substance, is just pure carbon arranged in a special way. Talk about a glamorous element. Next up, we have the nitrogen group in Group 15. Nitrogen, a gas that makes up most of our atmosphere, is essential for plant growth and even explosives, but be careful. Too much nitrogen can be a bad thing, polluting our water and air. And finally, we arrive at Group 16, the oxygen group. Oxygen, the gas we breathe, is crucial for respiration, the process that gives our bodies energy. But here's a fun fact. Oxygen can exist in different forms, or allotropes. We breathe in diatomic oxygen, but there's also ozone, a gas that protects us from harmful UV radiation. Section 5. Demystifying halogens and noble gases. Hold your breath as we enter the world of the halogens in Group 17. These nonmetals are highly reactive, meaning they love to gain an electron. They're found in everything from table salt, which is chlorine, to toothpaste, which is fluorine. They're even used to disinfect water and kill bacteria. But handle with care. Halogens can be toxic in high doses. Remember, even the most dangerous elements have important uses. And last but not least, we reach the noble gases in Group 18. These elements are like the introverts of the periodic table. They're very stable and don't like to react with other elements. That's because their outermost electron shell is full, making them happy and content. Helium, the gas that makes balloons float, is a noble gas. It's also used in MRI machines and even to cool down rockets. Neon, another noble gas, gives off a bright red-orange glow when electricity passes through it, perfect for those flashy signs. Argon, R, makes up about 0.93% of Earth's atmosphere, making it the most abundant noble gas on our planet. Commonly used in welding and as an inert gas for preserving historical documents. Krypton, Kr, produces a whitish light when ionized, often used in high-performance lighting and flash photography. Denser than air but still chemically inert. Xenon, Z, capable of forming compounds under extreme conditions, such as xenon hexafluoroplatinate, the first noble gas compound discovered. Used in headlights, medical imaging, and ion propulsion systems in spacecraft. Radon, Rn, radioactive and the heaviest noble gas, found in trace amounts from the decay of uranium in the Earth's crust, historically used in cancer therapy, although its radioactivity poses risks. Exceptions and interesting facts. Reactivity of heavier noble gases. While noble gases are mostly inert, xenon and krypton can form compounds, particularly with fluorine and oxygen, under extreme conditions. This reactivity increases as you move down the group. Radon's radioactivity. Unlike the other noble gases, radon is radioactive. This property makes it unique but also hazardous in confined spaces like basements where it can accumulate. Helium's superfluidity. Liquid helium demonstrates unique quantum properties like superfluidity, which allows it to flow without viscosity. So there you have it, a whirlwind tour of the periodic table groups. By understanding the properties and trends of these groups, we unlock a deeper understanding of the elements that make up our world. Keep exploring, keep asking questions, and never stop being curious about the world around you.